up during the first 50 sols at the surface of Mars, and then the temperature starts slowly going down. So while the temperature is going up, those things are absorbing water from the atmosphere and getting a little bigger, and the amount of salt is diluting. And then when the temperature starts going down, then that water is going to start to freeze. But there is also superimposed inducing the diurnal cycle. So we believe that those droplets would partially freeze during the night and then melt again during the day. And the other thing that really caught our attention was the fact that there is a change in the brightness of those droplets. And change in brightness is associated with change of phase of water. Like the liquid appears to be darker than the ice or the salt crystals.
And, of course, one of the other things that we learned from Phoenix is that, indeed, this soil around the lander was extremely salty.
That's true. But first, we saw those things before we discovered the salt. And so at the beginning, there were people that were very skeptical because they were saying there is no evidence that there are salts there. Huh. And what I was saying is, I'm just looking at the images. And what's going on in the images tell me that there is salt there. But then after we detect the perchlorates, then it was amazing, I think, that the case became much, much stronger.
Phoenix Lander co-investigator Nilton Renno will tell us more about liquid water on Mars when we return. This is Planetary Radio.
I'm Robert Picardo. I traveled across the galaxy as the Doctor in Star Trek Voyager. Then I joined the Planetary Society to become part of the real adventure of space exploration. The Society fights for missions that unveil the secrets of the solar system. It searches for other intelligences in the universe, and it built the first solar sail. It also shares the wonder through this radio show, its website, and other exciting projects that reach around the globe. I'm proud to be part of this greatest of all voyages, and I hope you'll consider joining us.
You can learn more about the Planetary Society at our website, planetary.org/radio, or by calling 1-800-9-WORLDS. Planetary Radio listeners who aren't yet members can join and receive a Planetary Radio t-shirt. Our nearly 100,000 members receive the internationally acclaimed Planetary Report magazine. That's planetary.org/radio. The Planetary Society, exploring new worlds.
Welcome back to Planetary Radio. I'm Mat Kaplan. Liquid water on Mars? Right on a leg of the Phoenix Mars Polar Lander? It almost sounds too good to be true. But Nilton Renno says, believe it. The University of Michigan researcher is recapping for us his presentation at last week's Lunar and Planetary Science Conference. Renno leads the team that figured out how the salty soil found around Phoenix could protect those delicate droplets. Just like spreading salt on a road
exactly.
In the eastern United States. In fact, I'm sure it happens where you live in Michigan.
A lot here.
That salt, which lowers the freezing point of the water, is it fairly clear that it raised it to a higher temperature than was actually being experienced there?
Yes. In fact, especially because the strut there is in the shadow. Well, not especially. Because the strut is in the shadow, but also under the lander, that buffers the diurnal change in temperature. So the strut is warmer during the night and slightly colder during the day. And the fact that it's colder during the day inhibits the evaporation. But it's cold, but it's still warm enough for you to, even with the most conservative salt that we found there, perchlorate of sodium, to be liquid at the temperatures that we have there.
So here we were, though, up at the North Pole. If you were at the equator and had a similar composition of soil, a similar level of perchlorates or other salts, wouldn't we expect to see even more liquid water?
Exactly. If you need two things. You need the salt. You need a little protection against the really high temperature that you get during the day. So that could be just a thin layer of soil. And you need the source of water. So what I claim in the article that we submit to the Journal of Geophysical Research is that if those conditions are met, and they are met over a very large area of Mars, then it's possible to have those small pockets of liquid, salty water.
Should Mars Reconnaissance Orbiter be looking for puddles on Mars?
I don't expect to see huge puddles, but because that would be really speculation. Don't know how much salt there is in the soil. Those things can concentrate the salt. My guess is that there will be small pockets of liquid brines around Mars, but I don't know. Maybe pools are possible if all those conditions are met. I didn't do that calculation, and I think it's a little bit too much speculation to say that.
Well, you're just being a good scientist, but it certainly gives Mars Science Laboratory a little more to look for.
Oh, yeah. In my talk at Lunar and Planetary Science Conference, I end up with a little joke that I said the Follow the Water theme should be update to Follow the Liquid Water.
It's good. I like that.
Yeah, people like that.
In the press release that was put out by the University of Michigan, where you are at the moment, there is one sentence that stands alone on its own in a paragraph, and it is this. Certain bacteria on Earth can exist in extremely salty and cold conditions. That's all it says.
It's not my sentence because I'm not an expert on life. I think this really grabs the attention. I think it's probably the reason why they put it there. And we don't know. I think my view is that we know life here on Earth, and we know that was evolving in less saline conditions. We know that liquid water is really necessary for life. We know that we have life in very extreme conditions that we didn't expect to find, like the hydrothermal vents and the Atacama Desert. I just learned that there is bacterial life in highly saline solutions, those perchlorate salt under rocks, absorbing water vapor from the air and creating a habitable environment. So I think speculation at this point, something that we should really look more carefully.
Well, I'm keeping my fingers crossed, which is something people have heard me say before about this possibility. An increasing, I will even say likelihood, that we may find some biological activity on this formerly dead planet. You presented this paper on behalf of dozens of colleagues on the team just a few days ago at the Lunar and Planetary Science Conference. How was it received?
Very well received. I was surprised that the room had, I heard, 500 people seated, and the hallways were completely packed with people standing, and no one challenged any of my assertions there. So I was a little surprised. I expected at least some debate, and looks like everyone agreed with what I said.
Peter Smith told us there would be some nice revelations at LPSC this year, but many more to come over the next few years. Do you agree with that? Are we looking forward?
Of course, yeah. The more we look at the data, the more we really understand everything that we are seeing. And I think it's a unique place. And the fact that theoretically you could predict that liquid water is possible there. We saw a bunch of hints. So we found out this salt, the perchlorates, that are really powerful antifreeze. And the ice was so close to the surface. And besides that, there is layered ice. It's hard to explain how it formed except for by the melting by those brines. And all this together, I think, tell us that we land in a wonderful place, and that as we look at the data more carefully, I think there will be more surprise, probably.
Thank you for some very exciting work on this.
You are very welcome.
We will once again refer our listeners to planetary.org/radio, where we'll have the link to the University of Michigan webpage that actually shows these little droplets of water, and where you can read a little bit more about this work, the finding of liquid water on the surface of Mars by a team led by our guest, Professor Nilton Renno, who is Professor of Atmospheric, Oceanic, and Space Studies at the University of Michigan, Ann Arbor. Thanks again, Dr. Renno.
Thank you very much, Matt.
We'll be back with Bruce Betts for this week's helping of What's Up? A look at the night sky. That'll be right after we visit with Emily.